were given that tan alpha is equal to 3 by 4, cos beta 5 over 13, and also given that angle alpha and beta are not in quadrant first. Here we given that alpha and beta are not lies in quadrant first. So now start the solution. Tan alpha is equal to 3 by 4, cos beta is equal to 5 over 13. Given that alpha does not lies in quadrant first, but the value of tan is positive. The value of tan is only positive in first and third quadrant. If alpha does not lie in first quadrant, then alpha must lie in a third quadrant. This implies that alpha lies in third quadrant. We know that tan alpha is equal to perpendicular over base. This implies that P is equal to 3, B is equal to 4. By Pythagoras theorem, h square is equal to h square is equal to p square plus b square. Putting the value of p and b, we have 9 plus 16, which is equal to 25. Taking square root on both sides, h is equal to h is equal to 5. Because h is length of side, it is always positive. Now sin alpha is equal to minus p over h is equal to minus 3 over 5, and cos alpha is equal to minus p over h. It will become minus 4 over 5. Now we start value of cos beta. Cos beta is 5 over 13, and given that beta is not lie in quadrant 1, beta is not lie in quadrant 1. Since we know that cos function is positive in first and fourth quadrant, in the question given that beta is not in a first quadrant, it means beta will be in a fourth quadrant. This implies that beta lies in fourth quadrant. Now we find sin beta. So we know that cos is equal to base over hypotenuse. So b is equal to 5 and h is equal to 13. Now we use Pythagoras theorem. H square is equal to p square plus b square. Square of 13, 169, is equal to p square. We have to find, and b square is equal to 25. 169 minus 25 is equal to p square. P square is equal to 144. Taking square root on both sides, p will be equal to 12. The value of sin beta is equal to minus p over h. We know that sin is negative in fourth quadrant and beta lies in fourth quadrant, therefore we use negative sign in the value of sin beta. It will become minus 12 over 13. Now we use the formula sine of alpha plus beta. Sine of alpha plus beta is equal to sine alpha cos beta plus cos alpha sin beta. Putting the values of sine alpha cos beta, cos alpha sin beta, sine alpha is equal to minus 3 over 5. Cos beta, given that 5 over 13, plus cos alpha minus 4 over 5 and sin beta minus 12 over 13. Multiplying these fractions, we have minus 15 over 65 and minus into minus plus 48 over 65. LCM of 65 and 65 is 65 and 48 minus 15 will become 33, which is required answer for sine of alpha plus beta. Now we find cos of alpha plus beta. Cos of alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. Putting the values of cos alpha cos beta and sine alpha sine beta, we have cos alpha is equal to minus 4 over 5 and cos beta given that 5 over 13 minus sine alpha here we find minus 3 over 5 and sine beta is minus 12 over 13. Multiplying these fractions, we have minus 20 over 65 and minus 36 over 65. Taking LCM, 65 and minus 36 and minus 20 will become minus 56, which is required answer for cos of alpha plus beta. Find sine of alpha plus beta and cos of alpha plus beta. Given that tan of alpha is equal to minus 15 over 8 and sine beta is equal to minus 7 over 25. Neither the terminal arm of angle of measure alpha nor that of beta is in the fourth quadrant. Now we start the solution. Tan alpha is equal to minus 15 over 8. Sine beta is equal to minus 7 over 25. Since given that alpha is not in quadrant 4 and we know that tan alpha is negative in second and fourth quadrant. If alpha is not in quadrant 4 then alpha must be in quadrant second. This implies that we can say that alpha is in quadrant second. By comparing tan is equal to perpendicular over base, the value of P is equal to 15 and B is equal to 8. By using Pythagoras theorem, h square is equal to P square plus B square. H square is equal to 225 plus 64. H square will becomes 289. Taking square root on both sides, h is equal to 17. Now we find sine of alpha. In second quadrant sine is positive, so sine is equal to p over h. It will becomes 15 over 17. But in second quadrant cos is negative. Cos alpha will becomes minus base over hypotenuse. The value of cos becomes minus 8 over 17. Since sine beta is negative in third and fourth quadrant, while in the question given that beta is not lie in fourth quadrant, this implies that beta lies in third quadrant. We know that sine of angle psi function is equal to perpendicular over hypotenuse. P is equal to 7 and H is equal to 25. By Pythagoras theorem, H square is equal to P square plus B square. So 25 square of 25 is equal to 625 plus 49 is equal to 49 plus B square. B square is equal to 625 minus 49. B square we have 576. Taking square root on both sides, B is equal to 24. And in third quadrant, cos is negative. The formula for cos function will becomes cos beta is equal to minus B over H is equal to minus 24 over 25. Now using all these four values, we find first of all we find sine of alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. Putting the values, sine alpha is equal to 15 over 17, cos beta is equal to minus 24 over 25 plus cos alpha minus 8 over 17 and sine beta is equal to minus 7 over 25, which is equal to minus 360 over 425 plus 56 over 425. Taking LCM 425 and we have minus 304 as required. Now we use the formula cos of alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. Cos alpha is equal to cos alpha, we have find that cos alpha is equal to minus 8 over 17. Cos beta is equal to minus 24 over 25 minus sin alpha is equal to 15 over 17 and sin beta is given that minus 7 over 25. Multiplying these two fractions, we have minus into minus plus 192 over 425 plus 105 over 425. Taking LCM 425 and 192 plus 105 297 as required. Question number 11. Prove that cos 8 degree minus sin 8 degree over cos 8 degree plus sin 8 degree is equal to tan 37 degree. We start the solution taking right hand side. Tan 37 degree is equal to tan 45 degree minus 8 degree. 45 minus 8 is equal to 37 is equal to tan 45 degree minus tan 8 degree over 1 plus tan 45 degree tan 8 degree. We use the formula tan alpha minus beta is equal to tan alpha minus tan beta over 1 plus tan alpha tan beta. We know that tan 45 degree is equal to 1 minus and sine tan 8 degree can be written as sine 8 degree over cos 8 degree over 1 plus tan 45 degree is equal to 1 and tan 8 degree can be written as sine 8 degree over cos 8 degree. Taking LCM in the numerator and denominator, since LCM of 1 and cos 8 degree is cos 8 degree and cos 8 degree multiplied by 1, we have cos 8 degree minus sine 8 degree. Similarly, in the denominator, cos 8 degree multiply by 1, we have cos 8 degree plus sine 8 degree. The denominator cos 8 degree is cancelled out by cos 8 degree. So we have cos 8 degree minus sine 8 degree over cos 8 degree plus sine 8 degree, which is left hand side